All right. Well, thanks again for having me. Give you a little bit of context about myself before we jump into the fun stuff. As Maggie mentioned, wrote a few books, but for context, for perspective, um, was an engineer for a while. Did the normal stuff, right? I was an engineer, so then therefore I became an architect, and therefore as far as I could go. So I had to become a manager, and I was a really bad manager. So I went back to architecture, and that was like the early 2000s, building like low latency, high throughput systems. Back then, it's kind of when I got involved in the Agile and XP space. Was lucky enough to meet a gentleman that became a dear friend, David Hussman, and so I learned a lot from him. He kind of framed up a bunch of my perspectives. Was an architect for Red Hat for a while. When I was at Red Hat, I even remember telling my peers at Architect we had great technology and horrible products. Uh, and I think that was interesting at that time because this is like 2011. Um, and the OpenShift platform was just coming out. And so I was looking at it, and it was beautiful technology. You could see how it would help people, infrastructure automation, cloud automation. But the fact that it was a CLI and it had 15 parameters you had to pass in, and if you got one wrong, you would never understand why you got it wrong, was led me to believe they were pretty bad products, but great technology. I digress. So wrote some books, was an architect actually for Red Hat for a while. Last 10 years, as Maggie mentioned, really been focusing with helping organizations just learn, make it easier to do work. The context today when we talk about product thinking and architecture, it's a talk that's evolved over the years, using a variety of techniques to make it easier to keep product connected with architecture. The story and the ideas I'll show you today come from a real experience working with some organizations. The first part will be their story, and then as we get a little bit further along, I'll change it a little bit so we don't show too much of the inner details. But I do want to point out that this isn't a theoretical thing. It's very real. But we'll get into that in a second here. But that's enough about me. There we go. Simple outcomes for you. Everything I'm going to talk about today, I fully believe you can do on your own. So there's no kind of magic behind it. We'll talk about strategic DDD. We'll talk about C4. I might mention some other concepts or contexts depending upon time. I do want to talk a little bit at the end around where my current thinking is going and my current experiments are going. Just to see if that sparks anybody interest for anybody. But ultimately, these techniques will help you keep product context consistent when you're thinking about architecture. This wonderful gentleman, Ward Cunningham, the creator of the wiki, he also created the term technical debt. What I think is interesting about the term technical debt is while many of us might attribute it to the code that we inherited, the code that somebody else wrote last week, or somebody else copied off of Stack Overflow, or the shortcuts we made to get something shipped. What I like about what Ward said, and there's a video I think from like 2020, like right when COVID hit, where Ward did this video about what he actually meant around technical debt. And what Ward said was that when we are building products and we're writing software, we are actually codifying our understanding of the product in code. We're taking our mental model of how the product works and we're putting it down in code. And we're doing it with the best understanding we have of the product. Now, what he says is the challenge becomes once people use the product and our understanding of the product changes, that model of how we thought it worked is no longer the same as how it actually needs to work and how it should work. And he called that gap. He called that technical debt. That the idea between our understanding of the problem today and how we codified it yesterday. So it was never like meant to be a shortcut in terms of anything. It was meant to be, we're continuously learning. And because we're continuously learning, we need to continuously evolve our model. And I think that's a beautiful statement. It really humanizes this idea of technical debt, but it also ties into this fact that we need to be continuously thinking about how the product actually influences our code, influences our architecture, and influences our decisions. So that's where we get into the using product for architectural decisions. So I lay this out here as an idea for you. Behind every architectural decision is fundamentally an assumption about your product. Whether you're making a decision that says you're going to go microservices route. Now, if presumably you're doing that for a good intention with your product, it's going to make your product more resilient. It's going to allow you to scale it in different ways and serve different customers different ways. But those decisions should be based in an assumption of your product, right? And so then the question then becomes, how do you appropriately evolve architecture as the product continues to evolve? So keeping these items in line. Before we get to the techniques, I want to start off with the very simple discussion around what is architecture. Now, this picture used to be funnier to me than it seems to be these days. In the earlier days of architecture, when I was back at the Mercantile Exchange in Chicago, I had to do things like this, where you had this stick figure, and that was the user, and you drew a bunch of boxes, and you used UML, and it would say very generic things, and then you would turn this over to teams, and they would have to build products, but it had no real context. It was just kind of boxes of responsibilities. I did it, and it didn't really work very well. What I think is much more interesting, or if you think about a perspective of architecture, is I think of it more of this way. My apologies, this is kind of a muddy picture. I think this is the only picture I could find, or I might even have taken this one. This picture is from the book Notes on the Synthesis of Form by Christopher Alexander. Now, if you don't know Christopher Alexander, he is a physical architect. He built actual buildings that people lived in. He built common spaces. He is also the gentleman that created the idea of pattern languages, which then influenced software development. And you have, I forget Gabriel's last name, who created the patterns of software. These ideas around language or programming patterns and language patterns came from Christopher Alexander. Putting that part aside, this picture from Alexander always stood out to me. He said that when you're building physical buildings, it was a constant trade-off. And so this is in this diagram here, it's meant to be almost a causal model. The minuses mean that the relationship between two things are inverted. The positive means the relationship is direct. So if you were to read this, the bottom one is economy and the one to the right is simplicity. So we would say something like, as we increase the economy of a building, we make it cheaper to build, we reduce the simplicity of how it is to build it. If the materials are cheaper, it tends to be harder to build it. If we increase the simplicity, we might decrease the performance. Putting aside how that affects buildings, what I would offer up to you is that all of the architectures and the products that we build have these types of relationships. No decision we make is independent in and of itself. It has a relationship, a causal relationship with other aspects of our architecture, other aspects of our product. And so I like this idea of architecture, this idea that it is a series of decisions that are interrelated that we have to be thinking about, and we need to have a proper context to make better decisions. Alexander went on to say that there is a risk when you're looking at architecture where the top picture might be the actual dependencies when you're building something. And the bottom picture here would be if we take a bias simplification of the actual dependencies and use that in our building. I've fallen victim to the bottom as well. An example of falling victim to the bottom is based upon our skills or based upon where we want to go, we then determine that that is how we will build the product. Because we're going to the cloud, or because we are a spring shop, or because we're trying to do a certain type of pattern, therefore the product will look like X. We take a biased simplification. Our technology bias simplifies the problem into a way that isn't optimal. I'm offering up for you that possibly a more optimal decomposition is using product to figure out how to group these decisions. It's still going to be hard. It doesn't remove the non-linearity of the decisions, but I'm looking for a better way of grouping it. And again, for me, it becomes product orienting. So again, I want to set context. For me, architecture is interrelated decisions, and I'm looking for a way where I can have a better grouping of decisions and not bias them based upon current states, current systems. So architecture is fundamentally about fit within context. My architecture and my context don't necessarily transfer over to your context. My architecture might not be right inside your context. So again, we need context to have appropriate fit. So now we get into this idea of using actual product context to ground our architecture. I like to think about, even in this phase, of having intentional architecture as opposed to accidental architecture, right? One way or another, you are going to have architecture, you are going to have design. It is better to be intentional about it and have reasoning behind your decisions than just succumbing to what happens. So here we start getting into the story. Now, the story I want to frame up for before we get into some of these techniques is a large organization, legacy application, 20 years old, right? To give you context, running in WebLogic 7 on Java 1.6 or something in the first version of struts, a very, very old technical stack. Now, beyond that, the technical stack isn't necessarily the problem. The problem becomes it started off as one team. One team could build the product, innovate, create new ideas for the company. It was great. Became a little too slow, so it became two teams. Became a little too slow, so it became four teams. And so I'm sure you can see this pattern. So the problem became it became slower and slower to meet the needs of the product. And therefore, the solution, to nobody's fault of their own, was adding more people up until they got to the point where they now had 14 teams that could not get anything done. Fundamentally, it was an architecture problem. When we started talking, they wanted me to come help teams deliver faster. They were going to reorganize. They reorganized every 6 months and nothing ever changed. So we paused and said, let's look at, in essence, the fundamental discrepancy between the product needs and the architecture, and then we'll start looking at what happens. Teams were constantly stepping on each other's toes. And so we started off when we introduced this idea of strategic DDD. Now, strategic DDD, there's domain-driven design. There's a strategic side and a tactical side. Strategic is, of course, the strategy, the decisions we want to make, the context we want to set, how do we want to set it up, and tactical becomes the implementation side of things. So the first thing we wanted to do is we use strategic DDD to actually model out the product to figure out how we would want the teams to interact and operate to be able to be more tightly aligned to the product. They were very closely aligned as product teams that couldn't get anything done because of architectural constraints. So we wanted to start off and say, where are the logical boundaries for teams? Have a model for it, and then start getting into the tactical side of changing it. So we introduced strategic DDD as a way of modeling the product. That's what they ended up with. If I left you with that, I would do you a horrible disservice. So let's talk about how we got there. Now, what we're looking for from a strategic DDD perspective is, where are the logical boundaries for teams? So we can have teams truly be independent, be autonomous, own their own internal architecture, and know how they communicate across teams. The benefit of that becomes simpler code bases for teams, simpler deployments, as well as understanding of whose responsibility is what in context of the product. The last thing I'll mention before I show you how we do this is there was the assumption here, again, for context, is we weren't figuring out the product. The product was already defined. And now we were just trying to say, how do we get the product needs in, how do we get the architecture in line with the product needs? So here's what we did. We got everybody together. And by everybody, I don't mean everybody, because 14 teams would be a lot of people. We got the product owners, the PMO office, the main product owners together, along with architects. So there was about 25 of us together. We started off with a technique called event storming. The technique is just a technique, but think of it this way. As a group, we got together and we said, tell me the important events that happen in the life cycle of your product. Now, for context, this is a financial advisor company, and so you can think of the way they would think about their product. There's a potential client that we get information on, and then eventually they become a client, and then eventually we trade for them, and then eventually they retire. But the first thing we did is we said, let's not talk about systems. Let's talk about the from your product and your customer's perspective. Tell me about the events that happen in the life cycle of the product that are important. We laid them all out. We laid them out sequentially. It was a lot more stickies than this, but this is the simplest view of it. That's how we started. Once we identified the events and had them in a sequential order that we agreed upon, the next question became, when does the context of the product change? Now, the context here means the most important thing for this company was the idea of the account. Now, if you look at this diagram a little bit, you can see prospectus. So they're not a client yet. They're just somebody we're talking to. And we want them to be a client. Some events happen, and eventually they become an actual client. They sign the documents. Now they are a client of ours. Now, once they are a client, we get some information from them, the beneficiaries, their bank information, but we can't do anything. The account is just an account, but as soon as we have their money, now we can actively invest for them. And so we can do stuff in that kind of context. And then eventually the account becomes a non-tradable account or a retired account. And then the context changes again. So think about that. Over the course of the product lifecycle, the main context changes. The account goes from somebody that is not actually a client to a client, somebody that is a client without any funds to somebody that has funds. We can't trade, we can trade. It is an active account to a non-active account. So these black vertical lines are when the context of the product changes. Now, when we did this with the group there was two ways that this was evident. The first way was there was a lot of stickies around account creating because that was a very important event to a lot of people. So we could visually see on this board that this was an important event. So when you do this with your teams, you'll see the important events where context is changing probably through that technique. Another way, now mind you, this is a product that was going on for 20 years. Another way was in the database. After we did this, one of the DBAs said, oh yeah, in the mainframe, that's when it goes from status I to status O and status O to status A. So even in the mainframe, in the data set, they knew there was various statuses for when the context of the account changed. Now, you could imagine the code base, because the way it grew over time, had all of these contexts in the code base everywhere. Case statements, if statements, everywhere. Because of that, everybody was always stepping on each other's toes because the context was always spread across all of the teams. The code was nasty. The testing was nearly impossible, right? Because of all these permutations. And so what we did here was very simply events, significant events, look for context changing. From there, we took a step backwards and we said, for these events, the yellow stickies, what triggers them? So you'll see these blue stickies like create account or assign agent or create prospective client. We walked backwards to then see the item that triggered the event if it was triggering other events. Because again, we're trying to add more fidelity to this map. Where we're going is trying to figure out what teams own what. But this is how we started getting there. So again, events, significant events when context change, go back and look for what triggers them, flush out in more fidelity. The black sticky notes that are a little bit smaller there that are impossible to read was just third-party dependencies. So again, we could visually see third-party dependencies. Once we had that, we could then talk about what are appropriate boundaries from a product context where teams could operate. So you could see something like here, like beneficiaries was a specific context that a team could own on their own, and they would know the context of it. They would know that it never involves anybody in a prospect, and it has very certain states to it. So when they started working on it, the testing became easier, the context was easier, the code was simpler because it wasn't blending contexts. And that one team could own that, and it was a boundary, and it was very tightly coupled to a product idea. We need beneficiaries, and we want to be creative in beneficiary standpoint. And you can see stuff for banks, and then in the middle there you'll see trading and the funding of the accounts. Those are two smaller circles in a larger circle because they actually had a necessary coupling. Turns out you need to have money to trade. And so those teams needed to work together, and it's a little bit different there. One context, right? Two different teams. But we identified that as a potential team. And then on the far right, the retiring of the accounts was a separate team. Now, I'll tell you this. This was first and foremost strategic DDD to find out where the contexts were important from a product perspective and how do we align teams more closely to product. Now, from here, it wasn't just we put sticky notes on a board, the work was done. We had to then get into tactical DDD. Now, what becomes interesting here is these circles are teams. They own their internal architecture and their internal implementation because now the architecture is contextually rich. The freshness of data for beneficiaries is not as important as the freshness of the accounts. And so the technologies contextually need to be different. So again, circles became teams, team boundaries, and then they implement their own architecture, tactical DDD inside of it. And we'll see a little bit about that when we go forward. Once we did this, we found out that even though they had 14 teams, they only really had the need for 7 teams. I'm not saying you fire 7 teams by any means. And it becomes, how do we get there is another challenge, right? But just I wanted to realize that the organization grew to 14 teams because they never kept architecture in line with the product needs. And so they had to address it. Took us about a year. After about a year of once we modeled this and working with teams, about half the teams, about 4 out of the 7, were actually at a spot where the new architecture was in place and they were now more independent and they could iterate and innovate more creatively with the product. But it does take time. This is how we started. This slide talks about team communication. I touched on it a little bit around the coupling there in the account funding, but I'm going to come back to this later on because I think it's interesting from a whole totally different perspective. But what's interesting here is we're talking about team boundaries and how they might communicate data changes across. But again, we'll come back to that aspect. The last thing I want to mention for you is if you do this event storming, kind of figure out your domain models, see how it might lay out to teams. The Whirlpool model, a Whirlpool exploration that Eric Evans talks about in DDD is exactly what we did and exactly what I would recommend. You come up with a scenario, walk the product lifecycle, you build out a model. That's kind of what you saw. Then we did little code probes with teams to see what we missed. That influenced the scenarios. Then we try a different scenario, see if it changed the model until we got to a point where it felt like the model was pretty stable, and then teams could start doing their tactical implementation. So again, it's not just we did architecture once, we were done. It was product context, talked about teams and domains, did little probes, did another scenario, saw if the model was good, and before we got teams running where they could then create their own internal architecture. From a timing perspective, this took, I want to say almost, probably about 2 months for us to go through scenarios and models and code probes. Now, that is being remote, working on this a couple hours a week. So it wasn't like it was nonstop for 2 months, but it's not something you're just going to sit down and figure out as a team. It does take time. To get started, mention event storming, look at events outside in, think about significant events, think about context changing, identify teams and boundaries. The tips I would give you are teams respond to events or publish their own events. Those are, kind of like those yellow stickies. When you do this with your teams and your organizations, be careful about inventorying systems. Nothing about what we did here was about all of the database jobs or all of the mainframe jobs. We had to figure out the context of the jobs to figure out where they fit in the life cycle, to figure out which team should own it, but be very careful that you don't just go through and do an inventory. When we started doing that, we found duplication everywhere. And so we stopped doing that and we just kind of said, let's just focus on the core product needs and then we'll figure out kind of like where those fit. And then a big challenge here that I didn't mention is when you get back here to these teams and these bubbles, the idea is that teams not only own their architecture, they also own their data, the smallest amount of data that is relevant inside their context. That was very challenging for the majority of the organization. The common pushback is we need one source of truth. Now, that's one of those statements that's very easy to say and very easy to agree with that actually has to me, no actual meaning. Because, and what I mean by that is nobody ever asks the question, show me all of my customers for all time and everything that they've ever done, through the history of our data. They always ask context-specific questions. Help me understand how much money was in this account when we started trading for it. Tell me about why this bank information failed. Help me understand, are we sending out the right forms for the beneficiaries? And so if the data questions are context specific, then having one master data source to rule them all just kind of muddies the question. And so if you think about it from that perspective, it makes sense for teams to own their data because the data is context aware. So again, product drives architecture, drives data concerns. So you will have challenges where you'll have to be rethinking data. Just wanted to give you that heads up there. Last idea in the strategic DDD space for you. In DDD, they'll talk about ubiquitous language. For our team, for our area, words mean one thing and one thing only. This is a very easy sniff test when you're working with teams. The first team I worked with after we did those models, they had a problem come up with the network. Turns out the network actually had 3 meanings to one team. Well, first of all, it meant, of course, the network and the performance of the network. It also meant if you were a prospect, your network was all of your friends and family, so we could also market to them. It also meant if you were an employer, your network was all of your employees because they were getting financial benefits as being part of this company. And so network had 3 meanings. If a team has a word that has multiple meanings, you don't have ubiquitous language, and you need to figure out how to solve that. Where do those words actually belong? Because if you don't, then that team is going to have cognitive overload because in their code base, even if they have that bubble, now words mean 3 different things. And now the context changes. We don't want context changing. We want clear, crisp context for our area. So look out for those signals. Again, use this idea of strategic DDD, reduce cognitive load, makes the team have just easier for the team to get work done. You can see your relationships and you get less coupling. As of course, your product evolves, so does your model, right? So use that whirlpool as you learn, update your model and go from there. I do want to hop in. So that was the strategic DDD side of things. Then you actually have to talk about how do the teams actually go about their architecture inside of their bubbles and their domains. They want to get big picture. They want to figure out how do we fit in this whole product delivery? How do I see who I consume and produce? How do I contribute? I love the idea of C4 modeling. This is if you're not doing C4 modeling, I think it's something, again, very approachable. You all can do it tomorrow on your own. C4 modeling, you can see the c4model.com. This is where I can't show you that what the teams came up with because it becomes a little bit more proprietary. C4 modeling is very simply just a way of visualizing systems and architecture. It's a pinch zoom view of the world. You start at a high level, an outside view, context, persona interacting with the system. You can zoom in, see more fidelity, zoom in more and more. What I loved about C4 modeling is we had consistent context of the product, and we could zoom in and see where teams fit, and we could zoom in more and see what they provided, and zoom in more if we wanted to get how they were building things. It also became a very simple way of socializing design and architecture because everybody had the same context. So if you haven't done C4 modeling, I'll walk through it a little quickly here, just so you have an idea. Excuse me. At the top level of C4 is, of course, the first C, context. So you'll see something here, this darkish blue item, a persona. Again, this is a generic example because I shouldn't use the financial advisor group. Persona interacting with a bluish box. The bluish box for the context, this becomes what we zoom in on. This is our system, and these gray become supporting systems. In this example, you'll notice a couple things. The persona, very product-oriented language, kind of what they're doing, active language between persona and these arrows. They view the account balance using our system. Our system gets account information from the mainframe. We send email. So again, anybody can understand and read this. It uses the context, the persona of what they're trying to achieve, and it uses active language to talk about what is provided. That's the highest level. So for the organization that I was with, that had the 14 teams, we had a C1 context that was across all of the teams because they in essence served one customer, and their 7 teams provided this system with supporting systems. Now, when we click on the system, we would zoom in, and at the second level of the C4 model, they call it containers. This dotted line, right, is just the inside of the dark blue box from the previous slide. So we can see what's inside the system. At the container level, don't think of it like Docker. Think about these as teams. Now, in this example, again, it's the generic one from the C4 model website. In the group I was with, we took at the container level, and this became the individual teams. The bubbles from before, there'd be a beneficiary one, there'd be a funding one, there'd be a trading one. And so you could very easily see the customer trades using the trading platform. They set up accounts and fund accounts using the funding platform, right? So you would have this context of the persona. You would be able to see how they interact inside and with the various teams, as well as how the various teams would interact. This was very nice because we could find if there's any duplicity across teams. And again, it kept it very contextually rich. How does my team serve the larger goal? What am I providing? We would do things similar, as you can see here. We talk a little bit about the language and the technology stacks inside here. So this is the first part where technology started becoming involved. We went from context, now we're inside of teams. Here's what the team stack looks like, but here's what they provide. If I were to click on any of these, I would go inside the team and I would see what the team provides. So if I were to click on the funding team, I could click on that and I would go to the third level, the components. So again, here's the teams that this component might interact with, or I'm sorry, this team might interact with. But in essence, inside this data box becomes the services and what my team provides to that larger context. So we could see things like services. We could see things like any kind of reporting, any kind of APIs. Here's what my team provides in a little bit more granular detail. Again, still in the context of the product, but it became this nice view of the world that says, here's my team and what we provide, that it interacts with these other teams. That if I zoom back out, that solves this customer's problem. We started from the outside and now we're zooming in. The last very nice benefit of this was that when security wanted to get involved, they could now see the context of what teams were doing. So security went from being a blanket statements, you can't do anything ever. That's a little harsh. They didn't really say that, but you get kind of idea that security was very kind of blanket statement. And now they could work with teams inside their C4 models to have context and talk about what security was appropriate for that context. So security became better. Inside here, when teams were talking about their services, the teams that I were working with that were changing their infrastructure, changing their architecture, they would call out their changes inside here. The account creation team went from, of course, everybody had the mainframe. They were no longer going to use a mainframe, and they were going to use MongoDB because the information that they were storing was very dynamic. And so they wanted a little more flexibility, and they also wanted better cacheability and some other aspects. And so they said they're going to have MongoDB, and they talked about the data they were going to store and how people could, the interface people would use to get any of that information, of course, through API calls. But again, they would socialize those decisions, but their architecture became their architecture in the context of the problem they were solving. So again, it was just this beautiful kind of like outwards in problem we're trying to solve, and then putting it all together. For sake of completeness, the fourth level of the C4 model is code. I will tell you this, we did not do this. I am not saying you don't need to do this. If it's beneficial to you, by all means, go about doing this. We did not do this because for two reasons. One is um, usually most IDEs can reverse engineer and auto-generate your code diagrams, your class diagrams. So that wasn't as, it wasn't a hard thing to create. But the other aspect is the benefit from having the conversations from the context into the teams, into the services, and actually having good design and good intentional architecture made these code class things so discrete and so obvious that the benefit wasn't there. We got 90% of the benefit from 1, 2, and 3, and the fourth one just wasn't as helpful. So we didn't really get into the C4, the fourth C of actually modeling. Again, for your context, if it's helpful, by all means do it. I just wanted to give you that aspect that we didn't do it because we got the value from the first three. The last item I'll mention for you, the benefit of the C4 model. As most organizations that I've seen have, this organization also had a challenge around testing. It was hard to test. The organization wanted more test automation, do more unit tests, do more integration tests, but automate everything, and it was very hard. Once teams started talking about their architecture, and knew their boundaries, and then talked about how they were going to implement their own architecture, we could have very direct conversations about testing. We could say things like, yeah, at the C4, at the code level, we want to have unit tests. And at our components, around the services we provide, we want to have integration tests. And then at this container level, when we're going across teams, we want to have some functional tests. And then at this high level, where we're talking across the system, we want to have a regression test. I'm not saying that that will click for your groups 100%, but I can tell you for this group, when we did this in particular, it clicked for those teams. They now understood the kind of boundaries of their tests and what tests they should have when. Don't break my units, don't break my methods, don't break my services, don't break other teams, don't break the product. And it had this rich context around it as it went through. So I love C4 modeling for the idea of testing. If you want to get started, use that product context as an example. Start at that C1, discuss actions and verbs, drill down, add your fidelity as you go, socialize it, socialize it, socialize it, get more information, and update it, of course, as you learn. The one quick call out I'll give you here is when you're doing the C4 modeling, do it appropriately, but look out for loops. I've seen situations where you almost have like a triangle where team A sends data to team B sends it to C sends it to A. So like just look out for kind of common sense loops that don't make sense, or like hub and spoke models. Everybody goes through a proxy to go to everybody else. Like those from an architectural standpoint and a product standpoint, that hub is going to become your constraint. And so you can see those things visually. And so look out for those. I know I'm running a little bit long here. I want to get to questions. I want to just give you 2 minutes here on my current experiments and thoughts. Now, there is products are at different needs at different times. And so by that, I mean, Kent Beck talks about explore, expand, extract. The IDO group has an SVG has a different model, but it's all kind of the same, kind of like, are we trying to figure out market fit? Have we found market fit and we're trying to grow? Are we at, kind of scale and now we want to kind of control costs? As well as when you look at your product and your product life cycle, there's areas that you're going to want to be innovative in and areas that are just kind of common stakes. And there's going to be areas, just like I mentioned with the funding and the trading, where you have necessary coupling and you want to work a certain way because you need to, versus other areas that are totally independent. Where I'm going with this is I think we need to uh, allow the context of the work and the context of the product and the people doing the work drive how the work is done. And I think it falls, I give you five kind of facets here around design and planning and build and deploy and work. Um, I'm sure there's more than that, but this is kind of where I'm going with this. Products evolve, banking changes. I'm gonna skip that for now just to kind of get to the meat of this. I think many organizations fall into this trap right now. Um, they have high component coupling, rough architecture. Because of the high component coupling, they plan a lot. They have to have more teams together to plan, which means it takes longer to plan. When it takes longer to plan, my observation is they plan for longer horizons. Instead of planning what we want to do next, we plan for the next 3 and 6 months. Also, when component coupling is high, it leads to higher cognitive load on teams. Teams are thinking about more things because they know they're planning, they're trying to build more than they should because they know it's coming up. When cognitive load goes up, defects goes up. When defects goes up, time to deliver goes up, right? It's a vicious cycle. You get more ideas, which increases coupling and just makes this thing get slower and slower. Many organizations have this challenge where uh, they're trying to do more and more without addressing architecture and the gap between product and architecture, and so they get in this vicious cycle of planning to do more. I hear this all the time. We want autonomous teams, but everyone is going to do everything exactly the same way. And I think that is one challenge that we need to break. Um, Communication versus collaboration. There's a difference between talking and building together, right? And I think that's something we miss. Anyway, where am I going with this? This vicious cycle. I think we have a choice. I think we could say when we have ideas and we're looking at component coupling, we can actually do something about it. Strategic DDD and C4 is one great way of doing it. But from another vector, I think there's also this aspect of planning. There's this idea in DDD called context mapping. So I'm going to show it to you real quick. And I indirectly showed you earlier, but I want to stress how context mapping should affect how your teams actually plan together. This example from the DDD book, you can see a couple things popping up here. You can see this conforms, there's a U and a D. Marketing conforms to billing, billing's upstream, marketing's downstream. There's these ACLs, anti-corruption layer, open host system. There's this little red area. This is like a shared kernel. These are just patterns in DDD for context. There's these 7 main patterns. You can see them kind of laid out here, or I'm sorry, 8 main patterns. But here's where it plays out. Let me just here get to you here. In this area with the organization we were with, there was necessary tight coupling from a product standpoint. Money and trading needed to go together. When a change happened with the money, trading had to know about it. When trading made changes in how they did auditing, the money and the funding had to know about it. There was a necessary coupling here. We could call it a collaboration or a high collaboration. This group actually even had this idea of a shared kernel. They had a shared library between the two. Because the product had a necessary coupling, this team should plan together. Now, that doesn't mean they need to plan more together or spend more time, but they actually need to actively work together and plan accordingly because their work was necessarily coupled. This group, between the bank information and how it was funded, they could actually create an anti-corruption layer, in essence, an abstraction between the two, so that they were not coupled, so that they would not have to plan together. They would have to do different engineering techniques to make sure they didn't break each other. But if we're intentional about this, then we can break this view of the world where there's 7 teams inside here, and they all need to plan the exact same way and follow the exact same cadence and plan everything together with the same horizons, because fundamentally the product doesn't need that. So we use strategic DDD to find the teams. We use C4 to talk about teams in their architecture. And then we come back to this idea of context mapping to figure out the appropriate ceremonies and ways for teams to work and collaborate together. Collaborate meaning actually build together, not just talk. I wanted to play this out there for you because, again, I hope that if you try this with your teams, you get to better architecture, and that would be wonderful. I hope you take it a step further and you say, now that we have a better architecture, do our ceremonies actually have to all be the same, or should the ceremonies and the way that teams work actually change based upon the context and the way the product needs? And now that we've actually created appropriate separation. So again, with cooperation, the shared kernel, you need high collaboration. You need to work together. Might not be planning. When you have that customer supplier upstream, downstream, you look for ways for it to decouple. Usually engineering practices help decouple teams so they don't have to follow everything the same way. And then the last one there, I didn't talk much about, but there's this idea of separate ways. If teams are working in essence on non-differentiators, but they're spending a lot of time planning together, that's a different problem to solve than just the planning aspect of it. So there you go. In closing, back in my day when I was doing architecture early on, it was stick figures and boxes, and that was never the job. I think the best architecture we can do is having modeling based inside context and product context that makes it easy for people to reason around decisions, write less code, make it easier to do great things. Take a world of possibilities, use context to deliver maneuverable systems that bring joy. The best thing I think any architect could have happen to them is that somebody 2 years from now says, man, it is so easy to work in this system. Everything is obvious with intent. And I believe it's because of the way we've gone about the design. How wonderful would that be if your teams were actually talking about how easy it was to work? I would love that. And I think you can all bring that to your teams. The quick recap there, we talked about using product context to guide architecture and teams. We talked about DDD, C4, some context mapping. Please, please, please remember, Ward, appreciate this idea of technical debt, the codification of our model. We know more tomorrow than we did today, and we need to appreciate that learning and always bring it back to the product and how we're going about building things. Simple books for you to check out. Weinberg's wonderful if you haven't read any of his way to look at problems. Of course, Christopher Alexander, thinking about trade-offs in architecture and physical architectures. And then, of course, the Paul Rayner's and Vaughn Vernon's books on DDD and event storming. I think if you read these, you'll have a nice foundation to do some of these techniques with your teams. That's what I got.